Hey guys, it's Bruno, the IB Math teacher. So welcome to week number 9. First of all, we're very close to the end. We have less than 2 weeks to your IB Math exams. Hopefully this challenge has been productive or helpful for you. In this Ace Your IB Math Exams in 10 Weeks challenge, we go through 5 different questions in all 5 topics in IB Math, and we solve these exercises together. They're very mixed. There are paper 1, paper 2 questions, there are easier ones, there are harder ones. This is a way for us to mimic your IB Math exam, which is around the corner, okay? So let's get through week number 9 now. If you've missed anything, you can find all links and all resources in the description of this video. And do share these resources with your colleagues so you guys can study together. And let's get to it. Let's get through week number 9. AAHL students, they have a strong background in calculus because they know how much calculus is contained in all 3 papers in the IB exams. However, let this be a slightly more challenging induction proof with differentiation type of problem. In this exercise, we need to show or to prove that the nth derivative, and this is a notation for the nth derivative with respect to x, of this function right here is equal to this, 2 to the n e to the x sine of root 3 times x. This x is not inside the root, plus n pi over 3 for all positive integers. And as you know, the same 5 steps are involved in any induction proof exercise. You have the propositional function, which is actually already written here. You have the base case, which in this case is p of 1, given that we're talking about positive integers. The first positive integer is 1. You have the inductive hypothesis, which is what we're going to assume that it's true. You have the inductive step, which is the most demanding step. And then you have the conclusion, which is just vomiting the answer, vomiting that sentence that shows up in every induction proof exercise. Now, I had already written the propositional function here. There's no secret here, but it was already here. So let's just jump to the base case, which is the second step in this process. As mentioned before, in the base case, we're going to evaluate p of 1. On the left-hand side, we will differentiate this function using differentiation rules, those being power rule, the chain rule, product, or quotient, whatever makes sense for this exercise. In this case, we have a combination of product and chain. So we have these 2 pieces, e to the x and sine of root 3 times x. The derivative is the derivative of e to the x, which is just e to the x, times sine, we leave this the way that it is, plus we copy the first one, which is just e to the x, and now we differentiate sine of root 3 times x, which is cosine of root 3 times x, multiplied by the derivative of the inside function, which is root 3. Now, when you work with the right-hand side, it will look like you didn't prove the base case. The right-hand side is 2 to the first power times e to the x, and just remember we're replacing 1 over here and over here, times sine of root 3 times x plus 1 times pi over 3. And knowing that this can be rewritten using the following identity as sine of root 3 times x times cos of pi over 3 plus sine pi over 3 times cos of root 3 times x, and also knowing that this is the same as root 3 over 2, and this is equal to 1 over 2. We have the following: 2 times e to the x, sine of root 3 times x divided by 2, plus cosine of root 3 times x divided by 2 times root 3. And if you FOIL these terms, you get exactly what you have on the left-hand side, which is e to the x sine of root 3 times x plus e to the x root 3 times cos of root 3 times x. Now, given that the left-hand side and the right-hand side, they're exactly the same, we can state that the base case holds. Now, let's move to P of k, which is the inductive hypothesis. Now, on P of k, which we're just pretty much replacing n's by k's over here, we're going to assume that the kth derivative of this function right here is 2 to the k ex sine of root 3 x plus k pi over 3. We are going to assume that this is true. And don't forget to write it down. Assume that this is true for some positive integer k. Now, all easy marks are gone. All that is left is the hard work of actually finding or calculating p of k plus 1, we're going to state what is p of k plus 1, and then by differentiating p of k, which we are assuming that it's this, we're going to get to the right-hand side of p of k plus 1. Now let's do this step by step. First of all, we write the k plus 1th derivative of e to the x sine of root 3x. And if everything is done correctly, we should get to 2 to the k plus 1 times e to the x, root 3x plus k plus 1 times pi divided by 3. Now, as I mentioned, we're going to use our assumption, which is the fact that the kth derivative of that function is equal to this. And we're going to differentiate this again with respect to x, and hopefully we're going to get to here. The idea is to get to here. So the goal is to get here. Now, using the right-hand side of p of k, which is the kth derivative, which we're assuming to be true, and differentiating it with respect to x. And the reason why that works is that if you differentiate k times and then another one, that means that you're differentiating k plus 1 times. We should get d dx of 2 to the k e to the x sine root 3x plus k pi over 3. Now over here we also have a product and a chain rule to be applied over here. And given that this is a constant, the derivative is 2 to the k times the derivative of these other two terms multiplied, which means that we're going to use the product rule and the chain rule for this one. So we have the derivative of e to the x times the sine function, which has a k here, there you go, plus e to the x times the derivative of the sine, which is cosine of root 3x plus k pi over 3 times the derivative of the inside function, meaning the derivative of this. The only thing that multiplies x over here is root 3, therefore the derivative of this is equal to root 3. Now, it doesn't look like we're getting anywhere because this is not the same as this, but trust me, we're getting there. And one step in the right direction is to multiply all this by 2 over 2, which sounds silly. Why would we do that, right? But the reason is, if we do so, we get the 2 to the k plus 1 over here. Given that we multiplied by 2 over 2, nothing's changed. It's just like multiplying by 1. And also, we still have this 2 in the denominator. We can FOIL it, which means that we're going to have half of e to the x sine plus root 3 over 2 e to the x cos, which starts to resemble the process that we went through in the base case. But let's see that happening. So we have 2 to the k plus 1 times half e to the x sine of root 3x plus k pi over 3 plus root 3 over 2 e to the x cosine of root 3x plus k pi over 3. Now, another thing that you can do to make this a little bit simpler is to factor out the e to the x, which gives us this. Now, one thing that you should keep in mind is that sometimes in induction proofs exercises, it's not going to be clear what the last few steps are. If that is the case, you can always go back to where you're trying to reach, which in this case is right here. This is the goal. The goal is to get to here and try to find the bridge which will link the last step that we have, or where we stopped, to the goal. So let's investigate this a little bit more. You could rewrite this, the goal, as 2 to the k plus 1 e to the x times sine of root 3x plus k pi over 3 plus pi over 3. This would give you, or these would give you, this arc right here. Now, why am I saying that? I'm saying that because if you view this as A and if you view this as B as two different arcs, what you have here is, again, sine of A plus B. And we did use this identity before when we were proving the base case, which means that this is the same as sine of A cos of B plus sine of B cosine of A, which can also be rewritten given that cosine of pi over 3, which is 60 degrees, is 1 over 2, and sine of pi over 3 is root 3 over 2. It can be rewritten as half sine of root 3x plus k pi over 3 plus root 3 over 2 cosine of root 3x plus k pi over 3, which is exactly what we have in the last step of our proof. It shows up right here. Therefore, we can backtrack this process, meaning go from here to here, k pi over 3, and on the next step to here, which is actually not the last step. The last step is the next one. We're going to add these pi over 3's as k plus 1 pi over 3. So let this be the last step in this process. And there we have it. Now this is equal to the right hand side of p of k plus 1, which we can see right here. Now notice that we did, again, was to backtrack the process. We went, instead of from here to here to here, we went the other way around. And we could only see that because we were focusing on the goal and using it to build a bridge from the goal to the last step that we stopped. Now the last thing that we should do is to write the conclusion. Kind of a boring part, but we need to do it. So given that p of 1 is true and p of k plus 1 is true, whenever p of k is true for some positive integer k, then by the principle of mathematical induction, PMI, p of n is true for all positive integers. In this exercise number 2, we have a nice little mix between a logs and between trigonometric functions. And converting this log to an exponential, which means going from the right to the left-hand side over here, we get sine of x to the power of 1 over 2, which is root of sine of x, equals cosine of x. If we square both sides, we get a sine of x, which is equal to cos squared of x. And by replacing this cosine squared of x by 1 minus sine squared of x, we get a quadratic equation in which we can use the quadratic formula to solve. Now that comes from the fact that we can replace sine of x by y, solve it for y, and then substitute sine of x back into y. So we have sine squared of x, which can be represented by y squared, plus y minus 1, which is equal to 0. Now y is, using the quadratic formula, negative b plus and minus the root of b squared minus 4 times a times c over 2 times a, which means negative 1 plus and minus the root of 5 over 2. Do notice that both the base and what shows up inside the log, they have to be greater than 0, meaning that the only possibility here is to have negative 1 plus root of 5 over 2 as our y, which means that sine of x is negative 1 plus root 5 over 2. So consequently, our sine of x, which has to be positive, is negative 1 plus root of 5 over 2. All right, so for this exercise number 3, we have a vectors question, vector applications. In this case, we have a plane. This is not a particularly hard exercise. However, tomorrow's exercise on vectors will be more demanding. But let's tackle this one first, okay? Consider this plane pi x plus y plus z minus 2 equal to 0 and the point 1, 2, 3. We can immediately verify if this point lies on the plane by substituting the x, y, and z coordinates into the equation. If we get a true statement, meaning 0 equals 0 or 2 equals 2, something like that, that means that the point lies in the plane. And in this case, it's not going to. 1 plus 2 plus 3 minus 2 is not equal to 0. So we know that it doesn't. We can sketch the plane over here, and we can place this point D over here. So this is pi, and this is D. Now we need to find the parametric equations of the line T that is perpendicular to the plane and passes through the point D. Now, given that the normal vector of this plane, which can be found in the coefficients of x, y, and z over here, it is also the direction vector of this line T, our parametric equations will look like the following. We have a point over here, x0, y0, z0, plus the coordinates of this direction vector times lambda or some other constant. We usually use lambda. Now what's missing here are the coordinates of a point that the line crosses, and we do have it. Of course, it was given in the exercise. The coordinates are 1, 2, 3. So these are the parametric equations. Now on to question B. Find the coordinates of the point M where the line T intersects the plane pi. Let me place point M over here. And in order to find the intersection between this line and this plane, we're going to replace X, Y, and Z into the equation of the plane. So we have X plus Y plus Z minus 2 equal to 0. So we have 3 lambda plus 6 minus 2 equal to 0, which means that lambda is negative 4 over 3. And by replacing negative 4 over 3 into lambda, we get the coordinates x, y, and z of this point, which is equal to negative 1 over 3, positive 2 over 3, and 5 over 3. So question B is done. And let me move our sketch over here. And we're going to sketch another plane, plane beta, that passes through the point D, and it's parallel to plane pi. Now, if it is parallel and it passes through point D, that means that not only plane beta has the direction vector, or actually the normal vector n, but also this point belongs to plane beta. Therefore, beta is x plus y plus z, and that is because the normal vector is 1, 1, 1, plus some constant d, which is equal to 0. Now we are going to replace 1, 2, 3 into x, y, and z, so we can get the value of d, which gives us the full equation of this plane beta. So 1x plus 1y plus 1z plus d equals 0. And right here we are substituting point D. So D is equal to negative 6, and plane beta is x plus y plus z minus 6 equals 0. This is the answer, and this is the work that we did. Now, finding the distance between the two planes, that's the same as finding the distance between these 2 points. And by using the distance formula, we have 1 minus 1 over 3 squared plus 2 minus 2 over 3 squared plus 3 minus 5 over 3 squared, and that is equal to the root of 16 over 3, which is 4 over root 3, which is the same as 4 root 3 over 3. So again, not a very complex exercise, but one that asks you to do a few things related to vectors and lines and planes. But we will tackle a harder example tomorrow. Now let's move to the next exercise. All right, so on to a probability question that might look a bit confusing, so hopefully we get to clear things up right now. So here's the situation. Hinata goes to school every weekday, so 5 days a week. On any day, the probability of her missing the train is 2 over 7, something that we can already fill out in our diagram. So missing the train is 2 over 7. Therefore, given that the sum of this should be 1, the sum of these two, this is 5 over 7, which is the probability of not missing the train. If she misses the train, the probability of her being late is 5 over 6. So missing means that the probability of being late is 5 over 6. Therefore, the probability of not being late when she misses the train is 1 over 6. Again, the sum must be equal to 1. And if she does not, the probability of being late is 1 over 10. So 1 over 10 and 9 over 10. So we are done with question A. Now, given that in one specific day she was late, find the probability that she misses the train. This is a conditional probability. The probability of A given B is equal to the probability of A and B over P of B. In this case, the probability that she missed the train given that she was late, that is equal to the probability of missing the train and being late over the probability of being late. Now, we can color code this, and the probability of missing and being late is this times this, so 2 over 7 times 5 over 6. We multiply these probabilities to get the probability of missing the train and being late, which gives us 5 over 21. Now on to the probability of being late. She's late if she misses the train and she's late, which we found already, or she does not, but still she gets there late. So that means 2 over 7 times 5 over 6, which we know is equal to 5 over 21, or which means plus 5 over 7 times 1 over 10, which is equal to 13 over 42. And we get 5 over 21 over 13 over 42, which gives us 10 over 13. All right, so we're done with question C. Now on to the most interesting one. Hinata always knows before leaving home whether she'll make it to the train station on time. So let's say that she's at home. Let's call this home. And let's say that she looks at the clock and she knows whether she's going to make it on time or not. She knows how long it takes to get to the train station. If she knows she's going to miss the train, then at home she calls an app, or she uses a ride-sharing app, and she spends $18 to get to school. However, if she believes she can make it on time, then she takes the train. But upon arrival, two things might happen. She gets to the train station near school and she's still late, so she needs to call or use a ride-sharing app, which costs $6, or she did get on time using the train and she just walks to school. Knowing that the train ride itself costs $3, how much on average does she spend weekly to get to school? Now let's break this down into three possibilities. She's getting dressed and then she looks at the clock and she's going to be late for sure. Therefore, in that case, which involves the probability 2 over 7 to occur, this possibility here will cost her $18. However, there are other two possibilities. Number one, she did catch the bus, but maybe, the train, but maybe the train was too slow and she needs to use an app, which will cost her. All right, so on to the most interesting part, which is question C. Hinata decides how to travel based on whether she will miss the train. What does that mean? It means that she's going to consider different options according to whether she can catch the train or not. If she knows she'll miss the train, let's say she's getting dressed, for example, at home and she runs late. So she knows she's not going to be able to take the train. She takes a direct ride to school using a transportation app, which costs $18. What this means is if she misses the train, this will cost her $18. And if she catches the train, well, we have two different options here. She can still be late or not. Catching the train costs $3, and the probability associated to it is 5 over 7, by the way. If she is still running late, she will need to pay an additional $6 because, well, she needs to use the transportation app to go from the train station to school. Now, if she's not, she can just walk to school, which is this second option right here. So let's consider these different paths. We have a probability of 2 over 7 that she misses the train, or 5 over 7 times 1 over 10 that she does not miss the train, but still she is late. Or third option, she does not miss the train and she's not late. And to find the expected value of the cost, we are multiplying each probability by the cost associated to it. So in this case, for example, 2 over 7 costs $18. 5 over 7 times 1 over 10 will cost $9, which is the train ride plus the transportation app ride, which is 6, or only the cost of the train ride, which is 3. So each weekday, she will spend in average $7.71. Therefore, in 5 weekdays, in average, she spends $38.57. All right, so for exercise number 5, a calculus question as usual. We have an optimization problem here. Ayla is producing the packaging of these caramelized peanuts. And this cone-shaped packaging is produced by removing a small sector from a circle with radius 12, as the image indicates. Now, the first thing that we can do here is to draw the cone. So this is how the packaging looks like. We have a radius of r. Now, this 12 over here is the slant height of this cone. And it's easy to see that that is the case if you take, for example, this circle over here and you chop off a sector from it. So the 12, it is right here. That's the radius of this circle right here. Now, if we cut it off, and this is not gonna look super pretty because I did this in like 15 seconds, we will get this cone right here. So there's the 12. Now that is 12. This is h, which by the way can be found right here as well. And this is r. Therefore, given that the volume is 1/3 pi r squared times h, and given that what we need to show does not include any h in it, we gotta find h as a function of r first. So consider this right triangle. We have 144, the hypotenuse squared, equal to r squared plus h squared. Therefore, h squared, which is 144 minus r squared, h is positive and negative, but it doesn't make sense to have a negative value. It is positive 144 minus r squared. Therefore, we have our height as a function of the radius. So our volume is indeed 1/3 pi r squared times the root of 144 minus r squared. What's harder in this exercise is to identify the fact that this 12 is the slant height. Everything else is just fine. Now let's jump to question B. Find dv dr, which means the derivative of the volume with respect to the radius. Now this is the volume. 1/3 and pi, these are just constants. What we actually need to differentiate here is r squared root of 144 minus r squared. And for this, we need to use the product rule. Let's call u or r squared, which means that du is 2r. Let's say that v is the root of 144 minus r squared, which by the way can be rewritten as 144 minus r squared to the half. By using the chain rule, we have the derivative of this root, so 1/2, 144 minus r squared to the negative half, times the derivative of 144 minus r squared, which is negative 2r. Therefore, dv, it is equal to negative r over 144 minus r squared inside a square root. The minus makes us drop the root to the denominator, and 1/2 means root. So that's why we have this as dv. So continuing, we have 1/3 times pi, u times dv, plus du times v. And if we use the root as a common denominator, which means multiplying this and the denominator by root of 144 minus r squared, we get negative r cubed plus 2r times root of 144 minus r squared squared, which means that the root is now gone. So we have 288r minus 3r cubed in the numerator and the root in the denominator. And by the way, we can simplify this even further by dividing this by 3, which gives us pi times 96r minus r cubed over the root of 144 minus r squared. And now, in order to maximize the volume, we are going to take this dv dr and make it equal to 0. That's how we find maxes and mins. And in this case, we're going to find the max. If dv dr needs to be equal to 0, that means that pi, 96r minus r cubed over the root, it's got to be equal to 0. Now, if we cross multiply this root, and we can do the same with the pi by dividing by 0, or actually dividing 0 by pi, we just get 0 on the right hand side, and all that we have left is the 96r minus r cubed that we have in the numerator here. We can factor out an r and break this down into 2. Either r is 0, which does not make sense with the context of this problem, or 96 minus r squared is equal to 0, which means that r squared is 96 and r is positive. It's got to be positive. The root of 96, also known as 4 root of 6. Now we're almost done. If this radius right here is 4 root 6, that means that this circumference, which by the way is the same as this, it is equal to 2 pi times the radius, so 2 pi r. Careful not to use this as the radius, it's this radius right here, because we're not finding this circumference, we're finding only from here to here, which is equivalent to this. So we get 2 pi times 4 root 6, which is 8 pi root 6. Therefore, this arc length right here is 2 pi times this radius, which is the whole thing, minus the green portion. And we know that arc length is theta, which is this angle right here, times the radius, which in this case, it's 12. So theta times 12 equals, and let me move this here, 2 pi times 12 minus 8 pi root of 6. We can divide everything by 4, so we get 6 pi minus 2 pi root 6, which means that theta is 6 pi minus 2 pi roots of 6 over 3, which can also be written as 2 pi minus 2 pi root 6 over 3 radians. And that is it. An exercise that's way more complicated than what it looks initially, especially due to the geometry of the problem. All right, week number 9 is done. We just have one more to go. I'll see you next week. Keep strong, be strong, stay strong, and I'll see you in 7 days. Take care.